Question 9 involves a geometric series. So I've written the first three terms out, and underneath I've given them the equivalent of a general geometric series A, AR, AR squared. And we've got to use algebra to prove that K is equal to 5 over 2. Well, if we divide the second term by the first term, effectively we will get R. Which is also true that if we divide the third term by the second term, we will also get R. Well, we've got an equation in K, so we can solve it. It's just going to be a bit nasty. Let's cross multiply, and I'm going to sit everything on the number 3. So that's the 9 now raised to a power 2, multiplying the old index, and that itself is multiplied by itself as we cross multiply. And this is equal to 3, and I'm not going to do anything with this side, 4k minus 5. So this multiplication, because they're sitting on the same number already, I can just add the powers. So that's the power of the first one, and we just add 2k minus 2. Ultimately, we're going to equate the power line. So therefore I get, let's do each of these terms separately. This itself will be 14 multiplied by another 2. So this will be 28, and we get minus. This is 4k, again multiplied by 2, so this is negative 8k, is equal to, what have we got here? This is 3 to the 6k minus 7. Now we equate the power line. I'm going to put the k's on the right hand side and the numbers on the left. The negative 7 becomes positive, so this turns into 35, and that's equal to 8 plus 6, so this is 14k. So therefore k is equal to 35 over 14, and I can take a common factor of 7 out, which is equal to 5 over 2, which is what they wanted us to prove. So I'm confident that that is the right answer. And in B, we have to find the sum to infinity. So here's the sum to infinity formula. We need A and R. Well, we know A. A is 3 to the 4k minus 5. Yes, I'm going to substitute my value of k in. But we need to know what R is. Well, R is one of these calculations we've made here. Pick one of them. It doesn't really matter which one. They both look equally awkward. So I've put the value of k being 5 over 2 into one half of this equation. Now I've just got to number crunch this down and find out what R is. 5 over 2 minus 2 over 2 is 3 over 2. And 3 over 2 multiplied by 2 is 3. So this simply becomes 3 cubed on the top, divided by, now this one. This is 7 minus 5, so this is 9 squared. And if you work that out, R turns out to be a third. And I might as well do A while I'm at it. A is equal to our old expression here, which is 3 to the 4k minus 5. K now being 5 over 2. So this is equal to 3. 5 over 2, 2 times 2, that's 3 to the 10 minus 5. So this is equal to 3 to the 5. And that's equal to 243. So our sum to infinity will be 243 on the top, and our bottom is 1 minus R being a third, so the denominator will be 2/3, and if you work that out, this comes to 729 over 2. And that will be the answer to part B and the end of the question.